Hello my dear students, this is your Akbar sir in front of you for a science class. And the class is designed for class 8 and this is video record class number 7. You see, luckily I will talk about chapter 7. And from chapter 7, I will today discuss from lesson 1 and lesson 2 and 3. In lesson 1, we'll talk about gravitation, and in lesson 2 and 3, we'll talk about gravity and acceleration due to gravity. Okay, so before starting our class, let's review what you learned in the last class. Okay, ready? Okay. Dear students, I will just show you some cue cards to answer. Your first question is, so electron distribution of chlorine. Okay, electron distribution of what? Chlorine. Can you say? Yes, thank you. And I think if you remember the rule 2n squared, then it will be very easy for you to give the answer of such type of question. Thank you. Next question is, what atoms are inert? Yeah, in your chapter 6, you learned helium, neon and argon are inert gas. They are inert because their outermost shell is filled up with the maximum number of electrons. That's why they never lose an electron or grab an electron. That's why they are inactive in the chemical reaction. Okay? And try to remember, Rayleigh and Ramsay, two persons first gave the idea about inert gas. Clear? Fine. And get ready for the next question. Can you see? Yes? Where's ion? Clear? Where's ion? Yes? Fine. Again, for your better understanding, I am telling you, charged atoms or particles are called what? Ion. My dear, now the next question, and I want to show last question also all together. You see what is cation and what is what? Anion. Just two brothers in two different boats. Clear? What is cation? Yes? Yeah. Positively charged atoms are cation, and negatively charged atoms are called anion. So you all have done excellent, and I think that you started very much and with full concentration. So everyone, please have a big clap. Okay, my dear students, now let us start our new topic. Okay, and what's our new topic? This is chapter 7, the Earth, that is the planet where we live, and gravitation. Okay, my dear students, in your family, you love your father, your mother, your brother, your sister, and in the same way, okay, they also love you. Why? It's because there is an affinity between the family members and with you, to you. Okay, this affinity, that is an attraction. Clear? This affinity, that is, it's an attraction. This is what? Attraction force. For what? You love each other. Right? Now, we'll learn what about this attraction force. What is this attraction force? And remember, this attraction force acts not only in your family, everywhere, every planet, not only in this Earth planet. This attraction force acts in the whole universe. Okay, so what is this attraction force? To make it clear, let us say and enjoy a story. One day, Newton, that is the eminent scientist Sir Isaac Newton was in his garden. Probably he was doing something, he was thinking over something. All on a sudden, what happened? An apple falls down. And this scenario made Newton a little bit astonished. What happened? So many questions arose in his head. Why the apple didn't go up? Why it fall down? So many questions. And after so many speculation, he thought that yes, each and every particle of this earth attracts each other. And after more and more experiment, the final decision was that each and every particle of the whole universe attract each other. And this attraction force is called what? Gravitation. So my dear students, I think you have understood what is gravitation. Just think about the sun and think about the moon. You know, the sun attracts the moon, and this attraction between the sun and the moon is gravitation. Right? But remember, if in two bodies, two things, one is earth, then what will be? It will not be gravitation. It will be turned another way. And this is gravity. What you will learn in lesson number 2. Gravity and acceleration due to gravity. But remember, the attraction force between two objects of the universe is gravitation. But when in two bodies, two things, one is earth, then this one will be what? Gravity. So it's very clear to understand that gravity itself is a gravitation. Just think the attraction force between your science book and the earth. Think you have just thrown out your science book, right? But it didn't go up, it fell down. Why? Because the earth, the center of the earth attracts the book. That's why it didn't go up. So the attraction between the earth and the book is gravitation. No. This is what? Gravity. So I think you have understood the difference between what? Between gravitation and what? Gravity. Okay? Fine. My dear students, we were talking about the attraction force. But remember, the value of attraction force, the value of magnitude, okay, depends on two factors. One is mass and another one is distance. Okay, let us clarify it. Look at the board. Think this is an object. Okay, think this is object A, and think this is another object, and this is object what? B. Okay, clear? As their objects, so they of course have their mass. So think for object 1, the mass is what? M1, and the mass of object B is what? M2. And of course, these two objects are apart from each other. That is, there is a distance in between two objects. That is object A and object B. Think the distance is what? D. That is, if two objects, think A and B, as these two objects are in the universe or think are in the earth, so of course they will attract each other as per the definition of gravity and gravitation. So there will have an attraction force. Okay, there will have a what? Attraction force. Right? Now you see And now you see here, okay, how much will be this attraction force? Okay, how much? Clear? First of all, try to understand the value of F will depend on their mass. One point. And second point, the value of F will depend on the distance. Okay, and this relation has been established by Sir Isaac Newton, that man who became astonished when the mango fall down. Okay, clear? And this is called Newton's law of gravitation and gravitational force. What called Newton's law of gravitation and gravitational force. Okay, so according to Newton's law, you see this attraction force, okay, will be proportionate to, okay, proportionate to the product of their masses. Product, that is just the multiplication of two masses. Okay, fine. And proportionate, this is the proportionate sign. A proportionate to the product of their masses. And here one mass is M1 and another one is M2. Okay, and think this is an equation. And think this is equation number 1. Okay, so from the first equation, it's clear that the attraction force between two objects will be the proportional to the product of the mass of two objects. Clear? And this relation, this mathematical relation gives you the information that if you increase mass, attraction force will also increase. If you decrease mass, then attraction force will decrease. Right? And another one, this attraction force, okay, will be, of course, proportionate, but what? Attraction force will be inversely proportional. Inversely proportional to the square of the distance. That is, it can be written 1 by d as inversely proportional and square of the distance. Here distance is d. Okay, and think this is equation number 2. And here equation number 2 gives us the information that if you increase distance, then what will be? Attraction force will what? If you increase distance, attraction force will what? Decrease. And if you decrease distance, attraction force will increase. Okay, fine. So all together you can write equation number 1 and 2 as F proportionate to capital G M1 M2 divided by d square. And this is what? Mathematical expression of Newton's law of gravitation and what? Gravitational constant. Okay, here my dear students, you can ask me, sir, what is this G? Yes, here the G is universal gravitational constant. Okay, fine. Now I will show you what is this capital G. My dear students, just think here one thing. When you will write G, then it will not be proportional sign, it will be equal sign. F equal to capital G into M1 into M2 divided by what? D square. Now you see, okay, if you think that mass is 1, that is 1 kg, and M2 again is 1 kg, and distance D is 1 meter, then what you get? Then you see F equal to G into 1 divided by 1 square, that is G. that is F equal to G. What you have got? You have got F equal to G. That means G is attraction force. G is attraction force. But when the mass of two objects, each one will be 1 kg, and the distance is 1 meter. That means when two objects having 1 kg each are kept at 1 meter distance, then the force, the attraction force that is applied or exists in two bodies, this is capital G, or universal gravitational constant. My dear student, I think now it's clear. Okay, fine. Now, let me erase the board. My dear students, what you have learned from the Newton's law? You have learned F equal to capital G m1 into m2 divided by what? D square. Okay, fine. Now we have learned that if distance is increased, then F will decrease, and if distance is decreased, F will increase. There is a good relation, and now I'll show you how. Think here m equal to 1, m1 equal to 1, m2 equal to 1, and d equal to 1. Then what will happen? G into 1 into 1 divided by what? 1 square. That is what? G. You have got F equal to G. When m1 equal to 1 kg, m2 equal to 1 kg, and d equal to 1 meter. My dear students, now keeping the mass same, unchanged. Okay, you will keep mass unchanged. That is, you will keep 1 kg, but you will double the distance. Then you see what will happen. You see F equal to G, m1 1, m2 1, and now d equal to what? 2. That is 2 square. Or what you can write? F equal to G divided by what? 4. Okay, clear? Or you can write F equal to G 1 by 4 into G. Now you see here for the first relation, that is when distance was 1 meter, okay, and mass 1 kg and 1 kg, then attraction force F equal to G. But when you have changed mass unchanged, you have kept mass unchanged, but you have doubled your distance, then you see corresponding force is now 1 by 4G. That is 1 by 4 of previous one. Okay, that is if distance is doubled, okay, keeping the mass unchanged, then the corresponding force will be 1/4 of the previous one. Clear? And this is very important relation. My dear students, try to understand it and you will practice it more. Okay, so in lesson number 1, you have learned what is gravitation, and you have learned the Newton's law of gravitation and gravitational force, and Newton's law of gravitation and gravitational force, and you have learned what is universal gravitational constant, and you have also learned that if distance is double, keeping the mass unchanged, then corresponding force is 1/4 of the previous one. Okay, so now we will talk about lesson number 2 and 3, that is gravity and acceleration due to gravity. Okay, so dear students, let me erase the board. Already in chapter lesson number 1, you have learned what is gravity. So I will not again talk about the gravity, but acceleration due to gravity. Acceleration due to gravity. You see, there are two terms altogether. One is acceleration and another one is gravity. That is the acceleration what is caused, what happened for gravity. This is called acceleration due to gravity. And what is acceleration? Acceleration, that is changing of what? Velocity in unit time. This is called what? Acceleration. Okay, so acceleration due to gravity is expressed by English letter what? Small g, and its unit is what? Meter per second square. Okay, now my dear students, we learn that this acceleration due to gravity, okay, becomes different at different places. Okay, clear? And also we established the equation g equal to gm by d square. Okay, fine. First of all, you see, think the mass of the earth equal to m, mass of an object near the earth equal to m. The distance between the object and the center of the earth equal to what? D. Okay, fine. You just see here I have written the mass of the earth equal to m, mass of an object near the earth equal to small m, the distance between the object and the center of the earth equal to d. Just you can show it like, think this is the earth, this is the center, and the object is here. Okay, and the mass of the earth is capital M, and the mass of this object is m, and the distance between the center of the object is what? D. Okay, fine. Now you see, according to Newton's law of gravitation and gravitational force, you can write F equal to what? You can write m into n. I mean product of two masses of two objects, and what? Of course there is a constant capital G, and what? Divided by what? D square, right? Okay, fine. What you can write? F equal to capital G into m divided by what? D square. Okay. Think this is equation number 1. My dear students, there is another relation between the force, attractive force or attraction force F and acceleration. Okay, and the relation is like F equal to mg. And think it is equation number 2. Okay, now you see in equation number 1, this is F equal to something, here F equal to. So this is F, this is F. So equation 1 and 2 can be written as how? mg equal to g mm what? By d square. Okay, fine. Now you see, from the both sides, as it's an equation, so from the both sides you can cancel m. So g equal to what? gm by what? D square. So my dear students, this is the equation for g, that is for acceleration due to gravity. Okay, so here from this equation you see g equal to gm by d square. Dear students, here capital G is a constant. and here capital M, that is the mass of the earth, it is also constant. So the value of G does not depend on or don't get changed for capital G and capital M, but here D is distance. So it is seen that here in this equation mass M, small m, is absent. It means that the value of G does not depend on the mass of the object. Wherever you go, no problem, mass will be the same. That is why the value of G is not affected, okay, or the value of G does not fluctuate for the value of small m. That is, value of G does not depend on the mass of the object. That is, acceleration due to gravity is mass independent. But here you see D, that is distance. Okay, so distance is a factor that affects the value of G. That is, the value of G depends on the position of the object, where the object is located from the center of the earth. Okay, so I think you have understood the equation, and from this equation there are so many questions. Say establish G equal to Gm by D square, or say show that the value of G does not depend on the value of M, that is the mass of the object, or think the value of G is mass independent. Okay, so I think there is no problem. Now my dear students, we will learn the variation of G, that is variation of the acceleration due to gravity. Why this variation? Here in the equation you see value of G is depending on the value of D, that is distance. Distance, that is where the object is located on the surface of the earth, or where. Okay, fine. My dear students, let me erase the board. Okay, now as you see, this D is the what? Distance between the object and the center of the earth. So if you think it as R, then in the place of D, okay, what you can write? You can write this is what? R square. Okay, that is G equal to Gm by R square. That is radius of the earth. Here R is what? Radius of the earth. Okay, fine. You see here I'll show you a cue card. What you can see? What you can see? This is the map of the world. Okay, map of the world. And my dear student, you see this is the polar region. This is polar region. This is equator region, equatorial region. And you see, although we think that the earth is round, but no, this is not an ideal spherical object. Okay, this is perfectly not spherical, a little bit compressed in the polar region. It means that, okay, from the center of the earth, if you find out the distance of any object located in the polar region, then R will be, the value of R will be less than the equatorial region. Okay, that is, here you see, if value of R, okay, decreases, is less, then value of G will be more. Okay, that is, as in the polar region, R is smaller than the equator region. That is why in the polar region the value of G will be what? More. Okay, fine. And in the same way you see in the equatorial region the radius of the earth is more. That is, here R is more. When R is more, then value of G will be less. That is, in the equatorial region the value of G will decrease, and from the equatorial region when we go to polar region, then gradually the value of G will increase. But my dear student, for the convenient of the calculation, a standard value of G is received, and this is 9.8 meter per second square. And my dear students, at the equator G equal to 9.78 meter per square, and in the polar region this is 9.832 meter per second square. Okay, fine. So I think you have understood why the value of G is different at different places. It is only for that the earth is not a perfect sphere. That's why. Okay, fine. Now, dear students, standard value of G is 9.8 meter per second square. What do you mean by it? What is the significance of this relation? It means that when an object, think there is an object, okay, when this object fall down, okay, then in per second, its velocity increases 9.8 meter per second. This is what do you mean by the value of G is 9.8 meter per second square. My dear students, this is all about from lesson 1 to 3. But for your better understanding, how much you have understood and how much concentrated you were, okay, let me check. Okay, so yes, you say what is gravitation? Yes, absolutely you are right, and have a big clap. My dear students, another one, you say, who forwarded the law of gravitation? Who? Yes, Newton. Yes, but my dear, listen, you will write the full name, that is Sir Isaac Newton. Your next question is, what is acceleration? Yes, you are absolutely right. Okay, accelerate is a verb, and from the verb the acceleration has come. From accelerate, it is acceleration. Okay, speed up something. Okay, and the value of acceleration G is what? 9.8 meter per second square, but it's the standard value. And I showed you what is the value of G in the equatorial region and what is the value of G in the polar region. Okay, fine. You all have done excellent. So again, have a big clap. Thank you. So we are just at the verge of our class. So some RQs of the lessons, and let me write in the board. Okay, fine. And of course you will have to learn them. You see, let me erase the board. Your first question is, so my dear students, our today's RQs are: question number 1, define gravitational force, universal gravitational constant, acceleration due to gravity. Question number 2, state Newton's law of gravitation and gravitational force. Question number 3, acceleration due to gravity does not depend on the mass of the subjected object. Explain. Question number 4, write the difference between gravity and gravitation. Right? And now your homework, and of course this is learn and write homework, and homework number 7, and this is RQ question number 3. Okay, fine. So my dear students, that's all for today, and I hope you will enjoy the class. If you have any problem, please comment us. Allah Hafiz.